Hello everyone, this is Tahir Iswat from Daffodil International University and welcome to the video of understanding one-time pad algorithm. What is one-time pad? It's a type of symmetric key encryption, meaning the same key is used for both encryption and decryption. The key for the one-time pad can be an alphabet or words or a book. It's theoretically unbreakable if is used correctly. Encryption process. Formula C equals to P plus K, where C is ciphertext, P is plain text, and K is the key. If the result of the C is greater than 26, which is the base of alphabets, we would mod the result to get a value in range. And if the result of the C is smaller than 0, we do this equation like C plus 26 into multiplier of C. Encryption process example. Here we need three things: plain text, key, and the starting alphabetical value, which is A for 0. Now in the following table, we have placed the initial given value of plain text and the key. After that, we will place the corresponding value for each letter of the plain text and the key, like A for 1, P for 16, P for 16, L for 12, E for 5, and E for 5, L for 12, E for 5, P for 16, H for 8, 1 for AI, N for 14, T for 20. Moving on, we will simply do the equation of P plus K. Here we can see the two values are greater than 26. To get this value in range, we will mod the value with 26 and make it in range. As we can see, no value is greater than 26 or smaller than 0. We will simply convert the numbers with the corresponding alphabetical value. And here is the ciphertext. After that, the decryption process. Formula P equals to C minus K, where C is ciphertext, P is plain text, and K is the key. And the rules for the decryption process is exactly same as the encryption process. Here we need three things: the ciphertext, key, and the starting alphabetical value. In the following table, we have placed the initial given value of the ciphertext and the key. After that, we will place the corresponding value of each letter of the ciphertext and the key, which is F for 6, B for 2, E for 21, B for 2, M for 13, and so on. Moving on, we will simply do the equation of C minus K. Here we can see 2 value is smaller than 0. Now we need to do things to get in range. Here we will simply do this equation like C plus 26 into modular of C. Here we will replace the C to P and get the value in range. Now we can see the minus 10 is converted to 16 and minus 14 is converted to 12. As we can see, no value is greater than 26 and or smaller than 0. We will simply convert the number with the corresponding alphabetical value. And here we got the apple again. Let's take a look through the code for one-time pad algorithm. Here we have the main class and 4 methods including the main methods. First of all, the encryption. In this encryption method, we have a scanner for taking user input as plain text and key. We have a condition that ensures the key length matches the message length. If the key length is smaller than the plain text length, the key would be repeated to the plain text length, and if the key length is greater than the plain text length, it will shorten to the plain text length. We have an empty error here. After that, we have a for loop which will run until the key length. For each character position I, it computes the corresponding ciphertext character using this formula. Here it subtracts the ASCII value of the character A from both plain text and key character, adds them together, and assign the result in the ciphertext array. Now, if the ciphertext character is greater than 25, which represents the index of Z in the alphabet, it subtracts 26 to wrap the alphabet. This is done to ensure that the resulting character remains within the range of alphabets. After that, it converts the ciphertext back to the ASCII representation of the lowercase letter by adding a to the computed value. Then we will finally convert the ASCII value to a character and construct a string from it, which represents the ciphertext. The decryption process is exactly same as the encryption process. Just we have slightly changed the formula from addition to subtraction. Now let's try to execute this. Run main. 1 for encryption. Ciphertext, plain text would be apple, and key would be elephant, ELEPHANT. So we got the ciphertext EATAL. Let's try to decrypt the message. 2 for decryption. Ciphertext would be EATAL. Key would be elephant, ELEPHANT. So here we got the apple again, which makes the code is completely working. Thank you.